Now we talk about the encoder and the decoder. So now we are using the encoder and decoder. Then we use the data transfer. So we get the data transfer, there's a signal data transfer and the parallel data transfer. The data can be transferred by the serially only one line, or the parallel means a separate line. Can be the transfer to the encoder and decoder. So when you using the encoder and decoder system, we also utilize the hexadecimal system. Hexadecimal system means a binary number is 10111 like this. So this is for the number to represent there are a lot of digits. So by using the hexadecimal system, we can reduce the number of digits. So in this case, we use the ASCII code. So ASCII code is representing of the character, representing the character by the binary number and the hexadecimal number. So those systems are utilized for the encoder and decoder. So lastly, I also talk about the decimal, binary, and the gray code system, and appropriate electronic circuit, digital circuits to represent the combination of the number. So those are I given you last week. Okay, this week I give you the sums for ASCII code table, and then I will continue the multiplexer. Americans are standard code for the information interchange. So this is the ASCII code. So we utilize a 7-digit code. So this ASCII code is represented by the 7 digits of binary code. So binary code as well as the hexadecimal code. So they are used for the sending the text between the computer, printer, and the word processor. So in the process control system, the information are sent by the digital format. So in this case, we use the ASCII code. So for example, character A. Character A is a binary code is 1000001. For the hexadecimal, that will be the 41. And the character B, the binary code is 1000010. Hexadecimal code is 42. And character small a. Small a is a binary code is 1100001. Hexadecimal code is 61. And for the 0, so the binary code is 0110001. So the hexadecimal is 30. And 9 is a binary code is 0111001. Hexadecimal code is 39. And space with the 0100000. So hexadecimal code is 20. So this kind of the code we utilize to transfer the data process in the digital data in the process of control system. So that we also utilize the encoder and decoder circuit. So last week I give you the encoder and decoder circuit. So digital logic is a connection diagram. Now we continue with the multiplexer. Its specials are used on the decoder encoder IC. This is a multiplexing. Multiplexing means in the electrical state, input is only one data line, but outputs are transmitted to a separate data line. So this is called as a multiplexer. Multiplexer input one line, output will use a separate data line. So in this case, so one data line we transmit as a separate signal. So we can draw as a multiplexer and demultiplexer. So this is called as this circuit is a multiplexer. Input with the separate input. So this is 1, 2, 3 like this. 4. So this is the separate input. So then we input 1, 2, 3, 4. Those are the inputs. So then we the multiplexer. So multiplexer is also we call as a data splitter. Data splitter. And then this is data transfer on the line. And here it's connected to this demultiplexer system. Demultiplexer means the outputs are separate line. 1, 2, 3, 4. So then we output. So input is one separate line, and we use the data splitter and then transmitted the output with the data splitter to separate line. So then we use this is a multiplexer or data splitter, and this is a demultiplexer. also we call it a data distributor. So this is we utilize. So in this case, we use as a 4-port single way switch. So in this case, both are that are 4-port single way switch. So 4-port single way switch are utilized. So the multiplexing is often used in the computer to transmit data over a single line. So that if you want to use it as tablet data, you want to transmit over a single line. In this case, we use for the multiplexer. So this is for the data splitter. So there's this multiplexer uses a construct by the digital gate. So AND gate and OR gate, AND gate, OR gate, and NOR gate. By using this one, we can use a digital gate. So this is the multiplexer system. So especially the process control system, sometimes the control signal need to be transmitted over a line. So in this case, we use a multiplexer and a demultiplexer. Multiplexer means for on the encoder system. So there is a 4 input 1, 2, 3, 4. So we are using the AND gate and the NOR gate. AND gate, NOR gate, OR gate, and the output is always single line. So this is the data splitter system. Data system input is several lines, but output will be only one line. So by using this input and the AB, so that will be the A bar, B bar, A bar B, AB bar, and AB. So those data combination can be added to the output. So this is for the output of multiplexer system. So in this case, we utilize as a IC will be as a 74150 IC. So this is the 16 input version. So it has a 4 address line, and also that we also utilize as a quad 2 input device 74AS57 IC or the 74AS153 IC or 74AS151 IC. Two ICs are utilized for the multiplexer. Now I give you the table for the multiplexer. So there will be the quad 2 input and the 2 4 input, 8 input, and the 16 input. So those are the output can be the true output or inverted output, or the inverted and true output. So those outputs are true output is the original one. When you put the A, output coming out is A. But inverted output is when you put the A, output is the invert. So those are output can be coming out from the those IC. So those are the multiplexer IC. Multiplexing means that we utilize as a process controller. In the process controller, we control the control signal. Control signal will be the digital signal over the line. So that when you use a process controller, we need to pick up the stabilizer input point, and then those data are transferred over the line. So in this case, we utilize a multiplexer and demultiplexer. So those are multiplexer, we can transfer from the serial data. So serial data means a data transfer method in which the EV is set up sequentially over a single transmission line. And where the data means that a data transfer method where the data is transferred over a number of lines. So here you see the data is transferred on a single line. So this way it is a serial transfer. The multiplexer input is a separate line. So that way the parallel transfer. Multiplexer output means a single line. So this is serial data transfer. So that in the data control signal will be the character or the space or the control command. Those can be represented by the binary code. So in this case, we utilize the ASCII. This is the American standard code for the information interchange. That standard code is utilized. So this standard code got 7 digits of binary number, and it also got a hash decimal equivalent. For example, the data A can be represented by the binary number 1000001 and hash decimal codes are 41. So this is the data transfer system we use. So when we use the data transfer system, we use the multiplexer. So multiplexer means that we use a decoder and encoder. So this is a multiplexing. So in the multiplexing, one data line to transmit the service signal. So apparently simultaneously. So in this case, multiplexer means the server line input and output with the one data line. And demultiplexer means the data distributor. Multiplexer is also the data splitter, and demultiplexer is the data distributor. So one data input and server line output. So the multiplexing often used in a computer to transfer the data over a single line. So especially we use the printed circuit board, track So those are present circuit board threads data are being transferred. So that we can construct this multiplexer and demultiplexer by using the digital logic gate. So in this case, this is a typical multiplexer. So there will be input, 4 input, output is a 1 output. So the color combination can be the A bar, B bar plus A bar, B plus AB bar plus AB. So this is what is our logic diagram for the 4 input, the multiplexer. So we utilize the IC to construct a multiplexer. So that one side is a quad 2 input. So we use for the IC is 74AS157, 74AS158, 74AS257, 74AS258, 74AS298. Those are the multiplexer IC. They can produce a true output or inverted output or latch output can be taken out. And also we also utilize the dual 4 input. So the IC will be the 74AS153, 74AS253, 74AS352, and 74AS353. So they can also produce the true or the inverted output. And also we use the 8 inputs IC. So the types are the 74AS151, 74AS251, 74AS152. So they can produce the combination of the inverted and the true output as well as the inverted output. And 16 inputs multiplexer IC is 74150 IC. So they can produce the inverted output. So those are the kind of the construction digital logic gate to construct the multiplexer. And this is the application of the digital IC. So we also utilize the multiplexer. Transferring signal data allowing the common data line. So in this case, when you use only the one data line, we can use the star-vector multiplexer to transfer the data. So we also utilize the transferring digital data allowing common data line. So transferring digital data allow a common data line. So to also we use the multiplexer. So if you want to transfer the digital data along the one data line, so we use the multiplexer. So now we also see the internet the diagram or the 74AS251 IC. So there will be 74AS251 is the 8 input and output will be only 1 output. So we can construct the internet diagram here. Then the input. So this is the I0 equal to 0, I1 equal to 0. I2 equal to 0, I3 equal to 0, I4 equal to 0, I5 equal to 0, and I6 equal to 0, I7 equal to 0. So those are data. And this is for the also we can use the output S1, S2, S1, S0. So output will be A, B, and C. So this is for ABC data, and this one will be the output.
Is that for like an ASCII code?
Yes.
For the ASCII code, for ABC.
Yes, 3 ABC. So we use the ASCII code and we can convert it to a 3 ABC. So then we use you can transfer the data straight like this. So then we use the input we use this is we call the passing voltage 5 volt. The 5 volt need to be connected to the I0 terminal, I2 terminal, and I5 terminal. And also you need to connect to the ground. So I1 and I2, I1, I3, I6, I7. So all are connected in combined and joined to the ground. So this means we have to get the voltage. The voltage of 5 volt is connected to the I0, I2, and the I5, and the I1, I3, I6, and I7 are connected to ground. After that data line will be 3 lines, ABC 3 lines, and output will be the Z is the output. So we can draw as a table diagram. So this is the truth table. A, B, C is our input line, and Z will be the output line. So the combination of data can be the A0, B0, Z0 when the Z will be the 1. And A0, 0, A0, B0, C1, Z will be 0. A is 0, B1, C0, Z will be 1. And similarly, is 0, B1, C1, and Z will be 0. A1, B0, C0, Z will be 1. A1, B1, C0, and Z will be 0. And A1, B1, C1, Z will be 0. So those are the combination of the data. So depending on the state of the ABC, Z will be the changing. So for the A0, B0, C0, Z1, A00, C1, Z0, and A0, B1, C0, Z will be the A0, B1, C0, so that will be 1.
And the output in a serial manner.
The output is serial. So A0, B0, that will be 1, 0, 1, 0, 1, 0, 0. So this is for the truth table. The A0, B0, C0, Z will be 1. A0, B0, C1, Z will be 0. A0, B1, C0, Z1. A0, B1, C1, Z0. A1, B0, C0, Z1. A1, B1, C0, Z will be 0. A1, B1, C1, Z will be 0. So this is for the output will be the serial number. So input will be the any number here, but only the output state will be the only one data format.
Can you show me the output format?
Output is
it's like 0, 0, out,
any combination of the number, but only output will follow the serial number. So this means that since ABC will use the input, so that one will output. So that is the output. So this is for we use that for IC. The IC is 74AS251 IC. 74AS251 IC. So this is the IC. That IC will be the input, but there's only one output. So output will be inverted output. Flip-flop. There are two kinds of logic. One is a combinational logic. Combinational logic means that we make this combination. So for example, we use a multiplexer or the demultiplexer. So the logic system is a combination logic. Combination logic means that you can see the AND gate, OR gate, NOR gate in the combination. So this is why we call that combinational logic. They don't have that memory. But sometimes every input state, some of the input state need to be memorized, and the output will depend on the previous happening of the input state. In this case, we have to utilize the flip-flop. So flip-flop has a memory the element included. So the flip-flop can memorize as a previous stage. Previous stage are memorized by the flip-flop, and then the output is the determined by the previous stage condition. So this is we call a sequential digital system. Sequential digital system means input is memorized, and the flip-flop produce output. So output is also depending on the input signal. So this is for the sequential digital system. Sequential digital system, we use a flip-flop or memory. Not only the input data, not only the input, also we can also include the set and reset device. So the sequential logic, the fundamental element of sequential logic is flip-flop. So combination logics are the multiplexer or demultiplexer. They have no memory. Output remains steady as long as the input conditions remain constant. Sequential logic systems, they utilize the memory device. So sequential, this is also the sequential digital system. So fundamental element of sequential logic is a flip-flop. So flip-flop will include the input also include the output and set and the reset device. So this is we call the SR device. So SR device also included in the flip-flop. So that we can draw the diagram on the flip-flop. So this is what is S line and R line. So that will be the Q and the Q bar. So S is the set and the R means the reset. Output will be the Q and the Q bar. So that we can also draw the truth table. The truth table is this output means that this one is the input. So this is output and the result. So input will be the S and R input. Okay, output will be the Q and the Q bars are output. So output is inactive, S is inactive, SI inactive. In this case, Q is doesn't coming out. This is for the no change, original condition. Then S is active, R is inactive. So then we will say Q will be 0, Q will be 1, Q bar will be 0. So that way condition will be the set condition. And so S is inactive. And R is active. So that will be Q will be 0, Q bar will be 1. So the condition will be the reset. And input will be S is active. The R is active. And so in this case, this saturation undefined. Undefined saturation. So this is the invalid. So this means that flip-flop function. S is a set or R is a reset. So depends when we set the value. Set the value means that S is active. R is reset is not active. So in this case, Q is 1. Q bar 0, so that condition will be the set. When the S is active, so and R is active, so the Q will be 0, Q bar will be 1, so reset. So the output condition is only 1, 0, 1, 0, they are changing. This is for the flip-flop here. So especially we can utilize for the flashing light. Flashing light means 0 and 1 are the changing. So long as you are put the set, so output is a flip-flop like this. But when you want the stop, you have to put a reset. So this is why we use the flip-flop IC. So this flip-flop, especially we use for the timer divisor or the counter, we use for the flip-flop. So flip-flop can be constructed by the NOR gate. So I construct the flip-flop by NOR gate. The NOR gate is our flip-flop. So this is construction of the NOR gate SR flip-flop. So this way is the R. Okay, this one is another NOR gate. So this is the NOR gate SR flip-flop. So we connect S here, R here, and this one we use output Q and the Q bar. So this is a SR flip-flop. So this is a SR flip-flop. We also follow the data diagram. This is a truth table. So this flip-flop is for the schematic diagram. This is for the case logic gate diagram. SR flip-flop we can construct by the NOR gate. Also we can also construct by the NAND gate. So this is NAND gate SR flip-flop. So SR flip-flops are the index of process control system. We utilize the flip-flop to make the counting or especially the counter or the timer. So those things we use for the flip-flop system in the process control system. So that we can construct the flip-flop by using the NOR gate or the NAND gate. So this is the NOR gate SR flip-flop. NAND gate system is you also need the NOR gate. So there are 2 NOR gate and the 2 NAND gates are required to construct the SR flip-flop. So this is the one NAND gate here, NOR gate and NAND gate will connect it. This is another NAND gate. So then we disconnection come to here, and this one come to this way. And this one is connected to the like this. So this is for the SR. So this connection is S bar, this is R bar. Output is a Q and a Q bar. So this is a NAND gate SR flip-flop. So NAND gate SR flip-flop also to utilize a D-bound switch. The NAND R is a flip-flop to the D-bound switch. So we use a single port double throw type. So single port double throw type. So this will say SBDD. So SBDD and the full resistor. So those resistors are utilized to ensure that open circuit voltage are the logic 1. Open circuit voltage. So open circuits are input. It's a logic 1. So this is for that we utilize for the SR flip-flop. So this is for the NAND gate. NAND gate we use as a D-bound switch. So then we output we use Q and the Q bar. So then we utilize for the 1. And this one will be 1, they also 1. So then we do switch here. So this is for the debounding switch. So this kind of thing we also use as a flip-flop as a debounding switch. Okay, so we also utilize for this is for we use a NAND gate. NAND gate is a debounding switch. Debound switch. With NAND gate. Also, we also utilize the debounding gate with the SR latch. So NOR gate. So this is we use the NOR gate here. This is a NOR gate. NOR gate we also use the SR flip-flop. So this is we use for the this is for 1, and this one we use this switch. So this is resistor. So this is for the output we use this is a Q and the Q bar. So debounding switch with the NOR gate. So we apply this either NAND gate or NOR gate, and then we use for the debounding switch. Okay, so this is for the one step of the flip-flop. Flip-flop function is output can be changed from the 1001 depending on that. So when you set the input, output with the 1001 like this, and reset, output will go back to the original state. This is why we use for the flip-flop in the timer circuit. So that when you use it for the timer circuit, in this case we need to provide the clock signal. Once you put the clock signal, output should be the change in the state frequencies happen. So in this case we use for the clock RS flip-flop. So this is we call it SR latch. Gated SR latch. Gated SR latch is the way of the clocked RS flip-flop. So we can include the cloud. You can include the cloud to the change to record the change of the output state. So this is we call it gated SR latch. Gated SR latch is cloud RS flip-flop. So this one we include NAND gate flip-flop, SR flip-flop, and combination with the and another 2 NAND gate and the gate connection. So this is the gated SR latch. This is for the gated SR latch. So normally the SR flip-flop is always directly depending on the input. Sometimes there is no more input, there will be no more output. So not always we can insert the input. So input condition need to be memorized. So because of this one, instead of using the SR flip-flop, we have to use the SR latch, the gated SR latch or the cross RS flip-flop. So the basic SR flip-flop responds to the input directly, which in the many instead cause the timing problem. To overcome this, it is a cross SR flip-flop used to store the data, the state or set or the reset terminal. So the set or the reset terminal, the situation need to be memorized. So we have to utilize for this is a disconnection. So this is for the SR less connection. So only when the flip-flop is enabled by another signal called the clock signal. So that we need to store the data only when the flip-flop is enabled by another signal called clock signal. So this is for the SR less. So SR less function is this is the basic of the SR flip-flop, but it also memorizes input saturation. You get provided another signal, gate signal. So now I draw the circuit for the gated SR latch. So then we got the 4 NAND gate. NAND gate 1, NAND gate 2, this is a Q bar. So this is another NAND gate. So Q, so this one will be connected here, like this. So this one will be like this. This is S, this is R. So that will be gate signal. So this is the S bar. This is R bar. So this is for the gate signal, gated SR latch. So the gated SR latch we utilize. So in this case, from the gate we can get the signal. Those signals are, this is the flip-flop. This is for the, we use the gate SR latch. So the SR data is passed into set or reset data. It passes into the flip-flop only when the gate or the enable signal is logic 1. So only with that data we pass it through this gate when the enable signal is logic 1. So can need to be give the signal so the data can transfer from the input to output. Otherwise the data will not transfer. But this data will not disappear. All those are used remove the input signal, that flip-flop still memorize the existing data. So this is why we use the flip-flop. Flip-flop can function is it can memorize the input data. But normally the combinational logic cannot memorize the data. Once the input signal is removed, everything will disappear. But flip-flop function, flip-flop still memorize the data unless it is connected to the reset. When the reset is connected, everything will disappear. But so long as once they enable, so the data can be stored by the flip-flop. Talking about the multiplexer. Multiplexer function is the input service data are combined to the ones output, serial output. So this is a multiplexer. So encoder function. So we use a multiplexer IC. So those are the kind of multiplexer IC 7 1x7, 7 1x3, 7 1x1. So this is the 2 input, 4 input, 8 input, 16 inputs are multiplexer IC. So those are multiplexer IC we utilize. So the inputs are a 5 volt and the ground connection connected to the I0 to I7 terminal. So ABCs are the input. So when you put the input, output is coming out. So that this is the truth table to the output that depends on the inputs condition. And another one is I'm not talking about the flip-flop. Flip-flop is the inner combinational logic system. The normal multiplexer, demultiplexer, they don't have any memory. Output remain steady as long as the input contains remain constant. But the sequential logic system, we need to memorize the input stage. So in this case, we use a flip-flop. The flip-flop can be constructed by the NOR gate or the NAND gate. So this is connection of the flip-flop. So this is schematic diagram of flip-flop. So S is A active, R A active output is no change. S edit, R edit, 1 0 output. This is set. S is in edit, R is edit, so that way we use Q0, Q1, so reset. We cannot put the two inputs edit together, so this is the antivirus or invalid. So the flip-flop function can be considered by the NOR or the NAND gate. So this is connection of the flip-flop. RS to U bar. RS are the input, Q and U bars are the output for the flip-flop. So at the main line, we also construct the NAND gate and the NOR gate for the debouncing switch. So this is debouncing switch. We use a single pole double type SPDD switch. So the full resistor is use the open circuit input and logic 1. So another thing is the gate or the SR. This means that normal flip-flop patches it's a standard problem because of to get the output, input must be present. So in this case, if you want to do this timing system, where we construct latch, SR latch. SR latch is this is based on the flip-flop, but we put additional choose NAND gate for the gate connection. The function is when you put the gate terminal, so SR will memorize the input state. So long as the gate terminal is present, so they memorize the initial stage. Only that you can destroy the initial state by inserting the input signal, so reset signal. So this is why the SR data is passed onto the flip-flop. Only when the gate or the enable signal logic 1, the flip-flop will store the RS data. It isn't at the instant the enable signal is removed. Although that you remove the enable signal, the flip-flop memorize the initial position. This is why we use the flip-flop in the control system. Sometimes we need to memorize the initial stage, so that in this case we use the flip-flop. So this is why we use the flip-flop for the timing system or the digital control system. So those are the flip-flops that we can utilize. Now that they are the kind of the flip-flop. So this is the SR flip-flop. SR flip-flop is just a basic principle. They are not commonly used devices. Because of this, some things can happen invalid. Some things are invalid because although you put the S and R edit, so output is invalid. So this is the disadvantage of the SR flip-flop. So in the flip-flop need to be the A flow. So the latest developments are the D flip-flop, T flip-flop, and the JK flip-flop. So I also give you the circuit diagram and the schematic, and there's a truth table for T, J, and the D flip-flop. The JK flip-flop as I told you, SR flip-flop. SR flip-flop condition is that sometimes it's an invalid saturation can happen. If you press the SR all together, the saturation is invalid, so flip-flop will not be working. So we need to overcome this saturation. So that we have to use the D flip-flop and T flip-flop and JK flip-flop. So this is for the diagram for the T flip-flop and T flip-flop. The combination of G and T, so we can produce the JK. So T flip-flop will be the true diagram. T means D input. So this is Q output, and Qn minus 1 means another condition. So second condition means that when the D is 0, Q0, Qn plus 1 is 0. And T0, Q1, Qn plus 1 is 0. This is reset condition. And T1, Q0, Qn plus 1 is 1. T1, Q1, Qn plus 1 is also 1. This is the third condition. So Qn plus 1 is the second condition of the output. Okay, so we produce also the JK flip-flop. The JK flip-flop overcomes the problem of the possible invalid output condition in the SR flip-flop. Why is that stay retaining the two inputs? So that we need to stay retain the set and reset input, but we need to overcome the invalid saturation. So there is a SR flip-flop, the JK flip-flop two tables. So then we use the JK, Q, and Qn minus Qn plus 1. Qn plus 1 is the second condition, the output. So that when you put the condition 1, J0, K0, Q0, Qn plus 1 is 0. J0, K0, Q1, Qn plus 1 is 1. So this is a no change saturation. And then I use the J0, K1, Q0, Qn plus 1 is 0. J0, K1, Q1, Qn plus 1 is 0. So this is the reset condition. And then condition 5, the J1, K0, Q0, Qn plus 1 is 1. And the J1, K0, Q1, Qn plus 1 is 1. So this is set saturation. and then we just put the input. So when you put the J and K at the one condition, J and K 2 input at the one condition. So that means that output is depending on the previous Q state. Second output depending on the previous state. This means that when you put the SSR, J and K all together, so this means that you press the set and reset switch all together. So start with the output. Output depends on the previous state. If the previous state is 0, and then the next state will be the 1. When you press the 2 input all together, and then it's also depending on the output, the previous state. Output depending on the previous state. If the previous state is 1, then output will be the 0. So the second state will be 0. So in the JK flip-flop, the output not only depending on the 2 input set and reset, it also depends on the previous state input. So QM plus 1 is the second state, Q is the previous state. So the output not only depends on the 2 input, it's also depending on the previous state. So that when you put the 2 input together, the output QM plus 1 is depends on the previous state. If the previous state Q is 0, then QM plus 1 is a 1. And when you put the 2 input together, output QM, second output QM plus 1 depending on the previous state input, output the 2. So that if the previous state output Q is a 1, then second condition will be 0. So this situation we call it a target saturation. So the JK flip-flop not only provides change, no change, reset and set, it also has a provision for the target saturation. So I draw the diagram for the JK flip-flop. So in this case, the JK flip-flop is better than the SR flip-flop. It's called the provision. If you put the 2 input together, output can count something. So depending on the previous state. But it's still got a something problem, especially for the edge. When you put the digital signal, this is for the this edge is a 0 to 1 increase, and this edge is a 1 to 0 increase. So at the edge condition, it's no problem. Flip-flop can follow. This is a going 0 to 1 or 1 to 0, it doesn't matter, flip-flop can walk. But what about the major saturation? The major saturation is flip-flop can still make the confusion whether what way he is due, because this will be the state as remain at the 1 saturation. So in this case, we have to utilize this better, this can cause a time delay. So time delay can happen, this is because the time delay. From the 1 to 0, 0 to 1 or 1 to 0 if that is a clear saturation. But the 1 to 1 or 0 to 0 saturation, this can also happen due to a time delay. So in this case, the master slave flip-flop can overcome this one. So master slave flip-flop is provided to overcome the problems caused in the JK flip-flop, especially for the time delay problem. So JK flip-flop is working on the edge. But the connecting the condition of JK flip-flop can give the problem due to the time delay. So the problem can arise from the fact that although the flip-flop change on the edge of the clock signal, there is a small time in the before and after the clock edge, during which input data must hold the header stable. This means that when you need to hold header input stable data during the time delay time. So in this case, we can use the master slave flip-flop. Master slave flip-flop can also provide a setup at 4 times. Setup 4 times means set as 0 and 1 saturation at the setting time, and before changing the state, sometimes we need to hold as constant data. So this is why we provide the master flip-flop. Master flip-flop means that there are 2 JK flip-flop. One is a walk as a master, and another one is a walk as a slave. So I draw the circuit diagram for the master slave flip-flop. So we connect up connection like this. So there are 2 JK flip-flop. So J and K, the first state will be the master. So JK are connected to 1, and Q is connected to the next state as J. So this is next state the slave state. And this clock signals are connected together, and K is connected to the output. So this is the Q. So this is the master and slave. So there are 2 kinds of signals. When the clock signal is high, so in this master will is enable, the slave will be the disable. Because this one is not it. So this is a slave disable, master enable. So the master output will be set according to the data present at the master input. So this means that so the output depending on the master input signal. And then so slave flip-flop is remains saturation unchanged. When the clock signal return to 0, so then slave flip-flop will respond to the output of the master. So only the slave will respond to the output of the master when the input clock signal is 0. So this means the slave is function is that depending on the input signal, sometimes it only allows the master input output, and only the slave will make the function when the output clock signal return to 0. So this is for the master slave flip-flop. So then, in the master slave flip-flop, we also I will draw it up. I will draw it as two table for the master slave flip-flop. So that will be the so I made a combination of the master slave flip-flop. So I made a combination between H trigger, JK flip-flop, and the master slave flip-flop. H trigger is only the H. So this is a cloud, only the H is working. But it will not work for the whole part. But in reality, only working on the edges and not do the accurate. So the flip-flop should respond to the whole part. The whole part means that this is the whole part. This is the only edge. Only working the edges and not so good. The flip-flop should be working on the whole part. So then, normally the edge trigger flip-flop is only working on the edge. But the master slave flip-flop is working on the whole part. So then I will give you the correlation diagram for the comparison diagram for the edge trigger and the master flip-flop. If I comparison in the two table, left will be the edge trigger, the another with the master slave. So the edge trigger flip-flop is the clouds are only the edge. So the flip-flop is working only the cloud edge. But the master slave is working on the whole part. So the edge trigger is a JK. So J low, K low, and Q is a Q0 and the Q bar 0. So this is the initial condition. But the J high and the K low, so the output will be the Q is a high and the Q bar is a low. And J low and the K high, so the Q will be the low and the Q bar will be the high. And when the J and the K's are high, so that will be the doggy situation. Doggy situation means the second output depending on the first output condition. And for the master slave, it follows the same operation, the same output function. Only thing different is it working on the whole part, not only on the edge. So this is for the master slave flip-flop. We use the timer circuit or process controller. Process controller, especially we require the timer. So timers are controlled by the flip-flop. So also the sequential data transfer. If you want to say, sometimes output need to be dependent on the input saturation. In this case, we need the memory device. So the flip-flop contains the memory device. So this contains the memory device, so that it is used for the sequential circuit. Sequential circuit or the timing process control circuit. We also construct synchronous data. So the JK flip-flop as an AD flip-flop. So AD flip-flop means asynchronous. So this means a preset and a clear state. Sometimes we are working on the flip-flop, not only give us the data input, sometimes we also need to clear the state, clear the condition, because sometimes you are working here on the initial working, after that you need to clear all the initial conditions. So in this case, we utilize the asynchronous preset and the clear. So asynchronous preset and clear function need to be provided for the flip-flop. So that on this flip-flop diagram, we put another two additional terminals. One for the PR means the preset terminal, and another for the clear terminal. So clear means the CL terminal. So these are also need to be provided for the flip-flop. If flip-flop with the synchronous preset clear, we use it like JK flip-flop. So that way J terminal, this is a K terminal, and this is a class terminal. And then this will output the Q and the Q bar. So this way we use a PR, the preset, and this is a CL, so clear. So this is the PR means the preset, and CL means the clear. So those are flip-flop saturation. We also draw the truth table. So that way input. So input will be PR, CL, clock, J and a K. So those are input. Output will be that this is the output. Output with Q and the Q bar are the output. So the preset is a PI is low, cloud high. So this will be the output. This also be the H and the L. And this one H and so you don't put any data. Output will be the LH. And if you put this one the PR low, cloud low, so you don't put any data for the cloud and the GAK, the output is the H and the H. And when you put the PI high, cloud is high, so in the cloud it's going to this S, the K low and K low, the output with the Q0 and the Q bar 0. So this is the initial state. The opposite to the initial state. Two things happen. So this one is a PI high, cloud high. And so this one is a cloud is a PR high, like CA high, cloud is going to the negative S. So in this case, J is high and the K is low. So output will be the Q is high and the Q bar will be low. And then so it's the PR high, CA high, and cloud is a provide the cloud. And so in this case, J is low and the K is high. So Q will be low and the Q bar will be high. And when you put the PR and the CS are high, and we working on the thread, H, so when you put the J high, K high, so that will be target straight. Targets are straight. And when you put the PI is high, and CS high, and cloud is also high, so we don't put any signal, so this will be the Q0 and the Q bar 0. So this is for the JJ flip-flop. JJ flip-flop, preset and clear. So this working is we can also provide another 2 extra input, preset condition and clear condition. So this is the working. So this means that cloud is high and then cloud is going down. So cloud with the negative arrow, like down arrow means the cloud is going down, H with the cloud is high. So cross means that no cloud or the no J input and K input. So outputs are depending on how the preset and clear signal are provided and how the cloud signal J and K are provided. So those are the state of the Q and Q bar output. So this is for the JJ flip-flop and synchronous preset and the clear are timing. So we talk about the encoder and the decoder. So now we are using the encoder and decoder. Then we will do data transfer. So we get data transfer, there's signal data transfer and the parallel data transfer. The data can be transferred by the serially is only one line, or the parallel means a separate line. Can be the transfer to the encoder and decoder. So when you using the encoder and decoder system, we also utilize the hexadecimal system. Hexadecimal system means binary number is 10111 like this. So this is for the number to represent there are a lot of digits. So by using the hexadecimal system, we can reduce the number of digits. So in this case, we use the ASCII code. So ASCII code is representing of the character, representing the character by the binary number and the hexadecimal number. So those systems are utilized for the encoder and decoder. So lastly, I also talk about the decimal, binary, and the gray code system, and appropriate electronic circuit, digital circuits to represent the combination of the number. So those are I given you last week. Okay, this week I give you the stamp ASCII code table, and then I will continue the multiplexer. Americans are standard code for the information interchange. So this is the ASCII code. So we utilize it.
So those are the shift register. So shift registers are we use a flip-flop and then we construct the shift register. So those circuits are for the shift register circuit. Here will be the shift register, the combination of the clock signal and 4-bit shift register connection. This will be the counter. Counter means we can utilize the counter to count the timing circuit. So this is the construction of the counter circuit through table. This is the up counter and the down counter. They are flip-flop connection and the counter circuit connection. Here we use the module of the counter. The module of the counter connection, you can see the diagram. This one will be the counter IC. Kind of the counter IC. Therefore, the timer circuit we utilize the kind of the counter IC. And also then we can utilize a 7-digit segment display with the counter IC. So here are the 7-segment display and the counter IC connection. Here we use the 4-bit shift resistor, the 4-bit shift resistor, and also the 4-bit shift resistor, shift right and the shift left. This is for the number circuit, number display circuit. The number display circuit, we can utilize a 4-bit shift resistor. And here will be the counter decimal system, the truth table or the counter decimal system. Here will be the up counter and the down counter connection diagram. So you have to look at those are delay diagram. So based on the flip-flop and the flip-flop and the master slave flip-flop, I give you guys a basic idea how the master flip-flop is working, flip-flop is working. And then based on this one, I give you the further diagram regarding the connection and also the development of the counter circuit, development of the display circuit.